Look at any photograph of the night sky, taken by our most powerful telescopes. What you see is a beautiful, glittering lie. You see spirals of deep purple, elliptical clouds of golden light, and irregular smudges of brightness scattered across the velvet darkness. Like glowing islands in a cosmic sea, to our eyes, these galaxies look close together. They look like neighbors, separated by manageable distances. They look like a community of light, huddled together against the cold of the void. But that impression, that feeling of fullness, is one of the most dangerous deceptions in all of astronomy. The images you see, the ones captured by Hubble or the James Webb Space Telescope, are profoundly misleading. They are breathtaking. Yes, they are awe-inspiring. Certainly, but they are a deception. And tonight, we are going to pull back the curtain on that deception. You see, your brain is doing something automatic and catastrophic. When you look at those images, it is treating the cosmos as a landscape. It sees galaxies positioned near each other on a flat plane, and it assumes proximity. It assumes they're close. The way houses sit across a quiet street, or the way boats float together in a safe harbor. Your mind fills in the gaps with an assumption of connection, because that is what your visual system was built to do. Millions of years of evolution, on the plains of the African savanna, trained your brain to judge distances based on how objects appear relative to one another. Something that looks close must be close. Something positioned next to another object must be nearby. This instinct served our ancestors well. It helped them track predators. It helped them find water. It kept them alive in a world that was only a few miles wide. But when you apply that same instinct to the universe, it betrays you. The galaxies you see clustered together in a telescope's frame are not clustered at all. They are separated by distances so enormous that the very word distance barely applies. Consider the Hubble Ultra Deep Field. It is perhaps the most famous astronomical image ever taken. Astronomers pointed the telescope at a tiny patch of sky, a patch so small that you could cover it with a single grain of sand, held at arm's length against the night. They kept the shutter open for 11 days, drinking in every single photon of light that survived the journey across the dark. The resulting image revealed over 10,000 galaxies. In that single, minuscule sliver of space, 10,000 galaxies, crammed into a frame smaller than a fingernail. When you look at it, your eye sees density. Your brain sees a crowded jewel box. It sees a universe that is full, connected, and buzzing with light. But here is the truth the photograph hides. Many of those galaxies, those tiny dots of light sitting side by side in the frame, are separated by billions of light years of empty space. Some of them existed when the universe was less than 1 billion years old. Others are relatively nearby. The image flattens all of this cosmic depth into a mosaic that looks like a crowded room. You would never guess, looking at that image, that the dominant feature of the universe it depicts is not the galaxies, but the absolute, terrifying emptiness between them. This is not just a minor misunderstanding. It is a structural lie. It makes you believe the universe is full in a way that implies connection. It makes you feel that galaxies are scattered like stars, reachable in principle, if not in practice. The reality is the opposite. Galaxies are among the most isolated structures in existence. The voids between them are so vast and so empty that even neighboring galaxies exist in a kind of cosmic solitary confinement. And the scale of that separation is something most people never confront, because every image they have ever seen was designed unintentionally to hide it. To understand why intergalactic distances are so terrifying, you first need to understand what a galaxy actually is, not as a word, not as a glowing shape in a photograph, but as a physical object with a real size that already exceeds anything the human mind was ever meant to hold. Before we dive deeper into the darkness, I want to ask you a favor. If you find yourself feeling the weight of these distances, If you appreciate these journeys into the deep unknown, please consider hitting the like button and subscribing to this channel. It genuinely helps us to keep making these long-form deep dives. It helps us keep the fires of curiosity burning in a universe that is mostly cold and silent. Thank you for being here. Now, settle in, get yourself comfortable. Let the world around you fade away, because we are about to leave the safety of our home and step into the most isolated reaches of reality. Our own galaxy, the Milky Way, is a monster. It is a barred spiral, containing somewhere between 200 billion and 400 billion stars. Each of those stars is a sun, many of them orbited by planets, moons, and worlds we will never name. The entire structure spans roughly 100,000 light-years. From edge to edge, 100,000 light-years. That means that a beam of light, traveling at 186,000 miles every single second, would still need 100,000 years just to cross from one side of our galaxy to the other. That single fact should stop you cold. Light is not slow. It reaches the moon in a second. It reaches the sun in 8 minutes. It passes the orbit of Pluto in 5 hours. Yet, this same light, moving at the absolute speed limit of the universe, would need over 1,000 human lifetimes just to traverse the structure you live inside. When the light now arriving from the far edge of the Milky Way began its journey, modern humans had not yet left Africa. Entire civilizations have risen and fallen. In the time it takes a single photon to cross our galactic home, this is the scale of a single galaxy, one island of stars, and you need to hold this scale firmly in your mind, because it is the ruler against which intergalactic distances must be measured. Whatever number you are about to hear, for the gap between galaxies, remember that the galaxy itself is already incomprehensibly large. The lie of the photograph is that it makes these titans look small. It makes them look like dust, but they are not dust. They are empires, and the distance between them is not measured in miles or even in simple light years. It is measured in multiples of galaxy lengths, and when you realize how large a single galaxy length already is, the multiples become devastating. Think about what that implies for our hope of connection. Even within our own borders, the speed of light is too slow to allow for a conversation. If you sent a signal to the other side of the Milky Way today, the response would not return for 200,000 years. Humanity as we know it would likely be gone before the first hello was even heard. And this is just our home. This is the densest, most familiar part of our corner of the universe. Beyond the edge of these stars lies a wasteland so absolute that the vacuum of space within our galaxy looks crowded by comparison. We often think of space as empty, but interstellar space is rich with gas, dust, and the magnetic breath of billions of stars. Intergalactic space, however, is something else entirely. It is a void so vast and so barren that it redefines what the word isolation means. As we prepare to cross that boundary, keep your eyes on the light of our home, for it is the last warmth you will feel for a very, very long time. In the chapters ahead, we will measure the true gulf between us and our neighbors. We will look into the great voids where nothing exists, and we will finally understand why the distance between galaxies is the most terrifying reality in the cosmos. Stay with me as we leave the shore and head into the deep. To understand why the distance between galaxies is so terrifying, we must first confront the failure of our own language. We live in a world defined by the small. We measure our lives in inches, feet, and miles. We understand the distance between our home and our workplace. We can visualize the length of a marathon or the height of a mountain. These are human-scale numbers, built for a human-scale world. But the moment you step off the surface of the Earth, the ruler you have used your entire life breaks. It becomes not just small, but utterly insignificant. To measure the cosmos in miles is like trying to measure the depth of the Pacific Ocean using the width of a single human hair. The numbers quickly become so large that they lose all meaning. They become abstractions, cold strings of zeros that our brains simply refuse to process. Consider, for a moment, the fastest thing we have ever built. In December of 2024, the Parker Solar Probe, a masterpiece of human engineering, reached a speed of approximately 430,000 miles per hour as it swung past the sun. At that velocity, you could travel from New York to Tokyo in less than a minute. You could circle the entire Earth in about 3.5 minutes. To us, this is the absolute pinnacle of speed. It is the fastest a man-made object has ever moved through the dark, but in the context of intergalactic space. The Parker Solar Probe is not moving at all. It is a snail crawling across a continent. If you pointed this probe toward the nearest large galaxy, the Andromeda Galaxy, and fired its engines at full speed, the journey would take approximately 4 billion years. 4 billion years, not 4,000, not 4 million. But 4 billion, that is roughly the current age of the Earth itself. To reach our closest major neighbor, we would need to travel at the fastest speed humanity has ever achieved, without stopping, for a duration equal to the entire geological history of our planet. Every volcano that ever erupted, every ocean that ever formed, the entire rise and fall of the dinosaurs, and the long, slow evolution of our species, all of it would happen while that ship was still crossing the first fraction of the gap. This is why our rulers are inadequate. This is why our fastest machines are useless. The distance is not just a gap in space. It is a gap in time. It is a chasm so wide that human history itself becomes a mere blink in the transit. To bridge this gap, we look to the only thing that truly moves fast: light. Light is the messenger of the universe. It travels at 186,000 miles per second. It is the absolute speed limit of reality, a cosmic barrier that no physical object can ever cross. At this speed, the universe seems to shrink. Light reaches the moon in a little over a second. It reaches the sun in 8 minutes. In a few hours, it has passed the outermost planets and left our solar system behind. We use light as our new ruler, the light year. The distance light travels in a single year. It is a colossal unit, roughly 6 trillion miles, and yet, even this ruler, the most powerful one we possess, begins to feel small when we look at the voids between galaxies. When you look at the stars in our own night sky, you are looking at neighbors. The stars you see are typically a few dozen or a few hundred light years away. They are part of our local community, but the moment you look past those stars and aim your gaze at the faint, hazy smudge of Andromeda, the scale shifts by a factor of 10,000. Andromeda is 2.5 million light years away. Say that number slowly and let it sink in. 2.5 million years. This means that when you look at that galaxy, you are not seeing it as it is now. You are seeing it as it was 2.5 million years ago. You are looking back into deep time. The photons of light currently entering your eye left Andromeda's stars before the genus Homo existed on Earth. Those particles of light have been traveling through the absolute, frozen silence of the void for the entire duration of human evolution. Every step our ancestors took out of the forests, every tool they shaped, every fire they lit, and every empire they built happened while that light was still in transit, still crossing the emptiness between here and there. By the time that light finally reaches us, the stars that emitted it may have changed, shifted, or died. We are looking at a ghost. A message from a past that is so distant, it feels like another reality. This is the time trap of intergalactic distance. It ensures that we can never truly know the universe in the present tense. We can only know it in the past. The farther out we look, the deeper we sink into history, and because the speed of light is a fixed limit, there is no way to bypass this. Even if we could send a radio signal to a civilization in Andromeda today, the response would not return for 5 million years. No conversation is possible. no connection can be made. The distance has turned the universe into a series of isolated bubbles, where every galaxy is a prisoner of its own era, locked away by the sheer, unyielding slowness of light. And yet, as we look across that gap, we must realize that Andromeda is the easy target. It is our closest peer, our gravitational partner. In the eyes of an astronomer, Andromeda is practically touching us. It is the first name in any list of nearby galaxies, but beyond Andromeda. The gaps don't just grow, they explode. The next major cluster of galaxies is 54 million light-years away. Beyond that, clusters lie hundreds of millions of light-years distant. Our light-year ruler, which seemed so vast when we were talking about the moon and the sun, starts to feel like a broken toy. We are forced to realize that the universe is not just big. It is structurally designed to keep us apart. Think about the emptiness that light must endure on such a journey. For millions of years, a single photon travels through a vacuum so perfect, it makes the space between Earth and Mars look like a crowded city. It encounters nothing. No dust, no atoms, no heat, just the endless, expanding stretch of spacetime. This void does not just separate galaxies. It erases the meaning of connection. It turns a neighbor into a mystery, and a distance into a life sentence. As we move deeper into this exploration, we must accept that our human intuition, our human numbers, and our human technology are all fundamentally inadequate. We are standing on the shore of an ocean that light itself struggles to cross, and the more we measure it, the more we realize just how far away everything truly is. To truly grasp the horror of intergalactic distance, we must first understand the titanic scale of the prison we already inhabit. We call it the Milky Way. To us, it is home. It is a vast, shimmering city of stars, a spiral of 400 billion suns, spinning in the deep. When we look up at the night sky, we see the dusty band of its disk stretching across the heavens, and we feel a sense of belonging. We feel as though we are part of a grand, crowded structure. But the word home is a comforting mask for a reality that is far more isolating. The Milky Way is not just a galaxy. It is a cage of light, so vast that even if we could move at the absolute speed limit of the universe, we would still be trapped within its borders for 1,000 lifetimes. The scale of our galaxy is the first true blow to our sense of significance. It spans roughly 100,000 light-years from edge to edge. In some newer measurements, which include the faint outer stellar halo, that number stretches toward 200,000, but let us stay with the smaller, more conservative figure, 100,000 light-years. To put that in perspective, remember that light travels at 6 trillion miles in a single year. Now, multiply that by 100,000. The resulting number is a 6, followed by 17 zeros. It is a distance that is mathematically real, but biologically and psychologically impossible. If you were to board a ship and move at the speed of light, you would have to wait 100,000 years just to reach the other side. Think about what that duration represents. 100,000 years ago, modern humans were just beginning to migrate across the planet. We were still sharing the Earth with Neanderthals. Every civilization, every language, every religion, and every piece of technology we have ever created has occurred within a fraction of the time it takes light to cross our home. If a signal were sent from one edge of the Milky Way, when the first pyramids were being built in Egypt, that signal would still have 95,000 years of travel left before it reached the far shore. We are living in a structure so large that it severs the connection between its own parts. A star on one side of the galaxy can never know a star on the other. They are part of the same system, but they exist in separate timelines, forever out of reach of one another. And yet, as immense as this structure is, it is mostly made of nothing. This is the great paradox of the Milky Way. We see it as a dense disk of stars, but in reality, it is a wasteland. If you were to shrink our entire solar system down to the size of a grain of sand, the nearest star, Proxima Centauri, would be another grain of sand sitting 4 miles away. The space in between is an absolute vacuum. Now, imagine 400 billion grains of sand, each separated by miles of empty space. This is the density of our galaxy. It is a graveyard of distance, where stars are merely tiny, isolated sparks. Floating in an ocean of dark, when we speak of the Milky Way being full of stars, we are using a relative term. In any practical sense, our galaxy is a void, punctuated by the occasional thermonuclear furnace. At the heart of this titanic prison lies a darkness even deeper, Sagittarius A star. Supermassive black hole, with the mass of 4 million suns, it is the gravitational anchor of our galaxy, the point around which everything we see revolves. It is a place where space and time break down entirely. Surrounding this center is the bulge, a dense, frantic region of ancient stars, crowded together in a cosmic dance. But as you move outward, into the spiral arms, into the region where our own sun resides, the gaps begin to widen, the silence begins to deepen. We live in the suburbs of the galaxy, a quiet, unremarkable arm called the Orion Spur. From our perspective, the center of the galaxy is 26,000 light-years away. Even light, the fastest thing in existence, needs 26 millennia just to reach the heart of our own home. Consider the isolation of our own sun. We sit in a pocket of space called the local bubble, a region of low-density gas created by ancient supernovae. Our nearest stellar neighbor is over 4 light-years away. To reach it, our current fastest spacecraft would need tens of thousands of years. We are an island within an island within an island, and this is the tragedy of the galactic scale. We are surrounded by hundreds of billions of suns, but the distances between them are so vast that they might as well be in separate universes. The Milky Way, for all its beauty, is a series of lonely campfires, separated by an abyss that we have no hope of crossing. But the true horror is not what lies within the galaxy. It is what happens when you reach the edge as you travel away from the galactic center. The stars begin to thin out, the gas clouds become sparse. The vibrant, colorful nebulae of the spiral arms fade into a dim, gray haze. You are approaching the galactic rim, the boundary between the empire of stars and the absolute nothingness of intergalactic space. When you stand at the edge of the Milky Way and look outward, you are looking into the most profound darkness ever discovered. There are no more stars, there are no more planets, there is no more dust to catch the light. There is only the void. It is here, at the galactic shore, that the light-year ruler finally snaps. We have spent this chapter talking about the incomprehensible size of our galaxy. But as you look out into the intergalactic wasteland, you realize that the Milky Way, for all its hundreds of billions of stars, is just a tiny, fragile speck. It is a single drop of light in an ocean of ink. The 100,000 light-years that felt like a prison suddenly feel like a cozy room. Compared to the distance to the next shore, the gap between us and the next major galaxy is 25 times the width of our entire home. Imagine standing on the edge of a great city, like London or New York. The lights stretch on for miles, a sprawling, vibrant civilization, and then you reach the city limits. You look out, and there is nothing, no other cities, no roads, no trees, just a barren, lightless desert that stretches for 25 times the length of the city you just left. This is the reality of our position. The Milky Way is an oasis, but it is surrounded by a desert so vast and so empty that light itself becomes exhausted trying to cross it. This is why the distance between galaxies is worse than you think, because even our prison, our massive, titanic, 400 billion star home, is nothing more than a grain of sand, sitting on the edge of an infinite and unforgiving abyss. As we drift further into the dark, remember the scale of this home. Remember the 100,000 years it takes light to cross it, Hold that number in your mind, and then prepare to multiply it. For we are about to leave the last of our stars behind and step into a region where light itself has nowhere to land. We are leaving the Milky Way. We are entering the great silence, and in this silence, we will find that our galaxy was not just a home, but a shield against the realization that in the grand architecture of the universe, we are not even a footnote, we are just a flicker of light in a darkness that never ends. Stay comfortable, breathe slowly. The journey is just beginning. We have crossed our own borders, and now we must face the 2.5 million light-year gap that separates us from Andromeda. We must look into the ghost light of our nearest neighbor and understand that even in a universe of trillions of galaxies, isolation is the only true law. Our home, the Milky Way, is now behind us, a fading, glowing smudge in the rearview mirror of the cosmos. Ahead lies only the void, and in the chapters to come, we will see just how deep that void truly goes. Now, as we drift away from the final, flickering stars of our own galaxy, we find ourselves suspended in the deep, intergalactic night. Behind us, the Milky Way has shrunk into a glowing oval, a beautiful but distant memory. Ahead, there is nothing but the black, but if you look closely, if you peer through the velvet darkness toward the constellation of Andromeda, you will see it, a faint, hazy smudge of light, a ghostly thumbprint on the fabric of the cosmos to the naked eye. It appears small. It appears fragile and manageable. It is none of these things. That smudge is the Andromeda Galaxy, and it is the first true reminder that in the universe, nearby is a word that means absolutely nothing. Andromeda is a monster, while our own Milky Way is a titan. Andromeda is an empire. It is a massive, barred spiral containing approximately 1 trillion stars. That is 1,000 billion suns, each one a thermonuclear furnace, each one a potential anchor for worlds we will never see. Its disk stretches across 220,000 light-years, more than double the width of our own home. In the year 2025, NASA released a mosaic of this galaxy, assembled from over 600 overlapping observations. That image resolved 200 million individual stars, and yet it captured only a tiny fraction of Andromeda's total population. It is a gravitational fortress, holding within it thousands of star clusters, and a central, supermassive black hole with the mass of 100 million suns. It is not just a neighbor, it is a rival empire, sitting across the greatest wasteland imaginable. And the gap that separates us is 2.5 million light-years. Say that number to yourself, slowly. 2.5 million light-years. It is a number that sits at the very edge of human comprehension. To help your mind hold it, think back to the Parker Solar Probe, the fastest machine our species has ever built. Moving at 430,000 miles per hour, this probe could cross the entire United States in seconds. But if you aimed it at that faint smudge of Andromeda, the journey would take 4 billion years. 4 billion years of traveling through the dark without a single stop, without a single atom to hit. That is a duration equal to the entire life of our planet Earth. Every mountain that has ever risen, every ocean that has ever dried up, and every soul that has ever lived would be born and turned to dust, while that ship was still in the first half of its journey. This is the terror of the neighbor. In any other context, a neighbor is someone you can reach, someone you can talk to, but in the cosmos, a neighbor is a ghost. Because the distance is so vast, the light we see from Andromeda today is not a live broadcast, it is a fossil. The photons currently entering your eyes left those trillion stars 2.5 million years ago. When that light began its journey through the void, the genus Homo did not yet exist on Earth. Our ancestors were not yet human. They were small, struggling creatures, wandering the plains of Africa, with no concept of the stars above them. Every single thing we have ever achieved as a species, every language, every city, every war, and every dream, occurred while that light was silently, relentlessly crossing the vacuum toward us. When you look at Andromeda, you are looking 2.5 million years into the past. You are not seeing the galaxy as it exists right now. You are seeing a version of it that existed before the first stone tool was ever shaped by a human hand. If Andromeda were to disappear today, if every one of its trillion stars were to vanish in a single moment, we would not know it for another 2.5 million years, for 25,000 centuries. We would continue to see its ghost in the sky, blissfully unaware that our neighbor was already gone. This is the temporal isolation of the universe. The distance is so great that it severs the present tense entirely. We are trapped in our own bubble of time, seeing only the shadows of things that used to be. And yet, this ghost is moving. Andromeda and the Milky Way are currently locked in a slow gravitational embrace. They are falling toward each other at a speed of approximately 250,000 miles per hour. Astronomers have confirmed that we are on a collision course. In roughly 5 to 7 billion years, these two empires of light will meet. They will tear each other apart. Their spiral arms will be shredded by tidal forces, and their trillion stars will be tossed into new, chaotic orbits. Eventually, they will settle into a single, massive elliptical galaxy. A structure we have already named Milkomeda. This is a confirmed trajectory, a cosmic destiny that is already written in the math of gravity. But do not let the word approaching deceive you. Even though we are falling toward each other at 250,000 miles per hour, the distance is so vast that this collision will not happen until long after our own sun has grown into a red giant and swallowed the Earth. The 2.5 million light-year gap is so wide that even 1,000-mile-per-hour approach barely registers. It is a slow-motion car crash, where the vehicles are millions of miles apart, and the impact takes billions of years to arrive. It is a reminder that even when the universe tries to bring things together, the sheer scale of space-time keeps them apart for durations that exceed the life cycles of stars. Think about the space between us and that smudge. Between the edge of the Milky Way and the beginning of Andromeda lies a region of almost total, featureless nothingness. It is a void so pure that it makes the vacuum of our solar system look like a crowded room. In this gap, there are no stars, there are no planets, there is no warmth. If you were placed in the center of this gap, halfway between the two galaxies, the sky would look black in every direction. The Milky Way would be a dim haze behind you. Andromeda would be a dim haze in front of you, and in every other direction, there would be nothing, no points of light to guide you, no radiation to warm you. Just a silence that has lasted since the beginning of time. This is what it means to be neighbors in the intergalactic sense. It means being two islands in an ocean of ink. You can see the fire on the other shore, but you can never reach it. You can see the light, but by the time it reaches you, the world that sent it has changed beyond recognition. We call Andromeda our companion galaxy, but it is a companion that we can never speak to. We can only watch it. We can only measure its movements and calculate its mass and wonder if, around one of its trillion stars, another mind is looking back at our smudge and feeling the same overwhelming sense of isolation. As you settle deeper into your seat or your bed, try to imagine that light. Imagine a single photon leaving a star in Andromeda's outer rim. It travels through the cold, dark, empty space for 2.5 million years. It doesn't hit a single atom. It doesn't encounter a single speck of dust. It just travels and travels through a silence so deep it would break a human mind. And then, after 2,500,000 years, it hits the lens of a telescope or the retina of a human eye. That tiny, microscopic hit is the only connection we will ever have with the largest structure in our local universe. We are separated by a chasm that light itself struggles to bridge. Andromeda is the closest, the brightest, and the most familiar, and yet, It is a 2.5 million year old ghost. As we leave this neighbor behind and look further out into the deep clusters and the great voids, remember the feeling of looking at that smudge. Remember the 4 billion years it would take to get there, because as we move into the next chapter, we are going to look at what actually fills that gap. We are going to look at the intergalactic medium, the ghost matter that haunts the space between empires, and we will find that the nothingness is even more complex and more terrifying than the distance itself. Settle in as we move away from the light and into the absolute, barren void. Now that we have measured the distance and felt the weight of the millions of years light must travel to reach us, we must ask a deeper question. What actually exists in that 2.5 million light-year gap? When we look at a photograph, we see the galaxies as bright islands, and the space between them as a simple, featureless black. We assume it is a total vacuum, a place where nothing exists, but the reality is far stranger, and in many ways, far more haunting. The space between galaxies is not truly empty. It is filled with something astronomers call the intergalactic medium, a thin, ghostly haze of hydrogen and helium that constitutes nearly half of all the ordinary matter in the entire universe. Think about that for a moment. If you added up every star in every galaxy, every planet, every moon, every mountain, and every living soul, you would only account for half of the normal matter in the cosmos. The other half, the missing half, is not locked inside galaxies. It is drifting, abandoned in the vast, frozen wasteland between them. It is as if the universe took half of its building blocks and smeared them so thin across the void that they became functionally invisible. This is the intergalactic medium. It is the ghost matter of the cosmos, a hot, diffuse plasma that haunts the silence between empires. But do not let the word matter deceive you. In the world we inhabit, we are used to density. The air you are breathing right now is packed with trillions upon trillions of molecules in every cubic inch. Even the interstellar space inside the Milky Way, which we call a vacuum, contains about 1 million atoms in a space the size of a cardboard box. But the moment you step into the intergalactic void, the density collapses. In the space between galaxies, you might find only one single hydrogen atom in a volume of space the size of a washing machine. The rest is pure, uninterrupted nothingness. Imagine floating in that void. If you were to reach out your arms and sweep them through the darkness, you could travel for miles and never touch a single particle of matter. You would be moving through a vacuum so perfect, so absolute, that no laboratory on Earth could ever hope to replicate it. It is a thinness that defies the imagination. If the space between stars is a desert, then the space between galaxies is a desert the size of a continent, with nothing in it but a single grain of sand. This is why intergalactic space is so terrifying. It is not just the distance, it is the lack of medium. There is nothing to carry sound, nothing to catch the light, nothing to push against. It is a structural loneliness that exists at the atomic level. And yet, there is a strange paradox hidden in this emptiness. This ghostly gas, this 1 atom per meter haze, is technically scorching. Observations from our most advanced X-ray telescopes suggest that the intergalactic medium is heated to temperatures of millions of degrees. It is a searing, energetic plasma, but here, the laws of our intuition fail us once again. In our world, million-degree gas would incinerate anything it touched, but in the intergalactic void, there are so few atoms that there is no meaningful transfer of heat. You could float in this million-degree plasma, and you would not feel the warmth. In fact, you would freeze to death almost instantly. You would be surrounded by particles moving with the kinetic energy of a furnace. But because they are so far apart, they would never hit your skin, they would never share their energy with you. You would be technically immersed in a sea of fire, while your body heat radiated away into an infinite, lightless cold. This is the character of the intergalactic medium. It is energetic, but lifeless. It is technically filled, but practically empty. It is a place where the normal categories of physical experience, hot and cold, full and empty, lose their meaning entirely. It is a wasteland that challenges the very definition of what it means for something to exist. This ghostly matter does not sit still. It is organized into a vast, three-dimensional network called the cosmic web. Imagine long, thin filaments of gas and dark matter, stretching across tens of millions of light years, connecting galaxies like the threads of a spiderweb. These filaments are the highways of the universe. They channel gas into galaxies, feeding the birth of new stars, but even these highways are impossibly thin. A galaxy sitting on a filament is like a single dewdrop on a web that is miles wide. The gaps between the threads, the great voids of the universe, are even emptier, containing almost no matter at all. As we drift further into the dark, we begin to realize that the universe is not made of things. It is made of nothing. The galaxies, for all their trillions of suns, are just a thin, luminous residue clinging to the edges of an architecture built primarily from the void. Half of the universe's atoms are lost here, suspended in a state of eternal, energetic isolation. They will never become stars. They will never form planets. They will never be part of a living cell. They are the missing half, destined to drift in the millions of degrees of silence, forever. If you were to spend 1 billion years in the intergalactic medium, nothing would ever happen to you. No star would drift past. No asteroid would cross your path. The single atoms of hydrogen would occasionally strike your suit. A tiny, microscopic reminder that you are not in a perfect vacuum, but other than that, there would be only the darkness. The light from the distant galaxies would remain frozen in the sky, unchanging, for eons. The silence would be so total that you would begin to hear the sound of your own nervous system, the hum of your own blood, a tiny, fragile rhythm in a universe that has no pulse. This is what fills the gap between us and Andromeda. This is the worse than you think reality. It is not just a long road. It is a road made of ghosts, a road where matter is so sparse that it barely qualifies as a place. We are moving through a region where the laws of physics are the only thing that exists. No chemistry, no biology, just the cold, mathematical expansion of space-time, as we leave this ghostly medium behind and head toward the great voids. We are going to see what happens when even these few atoms disappear. We are going to look into the Boötes Void, a region of space so empty that it makes the intergalactic medium look crowded. Settle deeper now. The warmth of the galaxies is far behind us. The light is growing thin, and ahead lies the most profound silence the universe has ever produced. We have spoken of the distance, and we have spoken of the ghostly matter that haunts the gaps between galaxies. But now, we must confront the most terrifying structure in the known universe. Not a structure built of stars, or black holes, or gas, but a structure built of absolute, unyielding nothingness. Astronomers call them voids. These are enormous, roughly spherical bubbles of space, where the density of matter drops so low that the laws of cosmic connection seem to vanish entirely. To understand the scale of these voids is to understand that the universe is not a collection of galaxies. It is an ocean of emptiness, where galaxies are merely the foam on the waves. Imagine a giant sponge. The solid parts of the sponge, the threads and walls, represent the filaments of the cosmic web where galaxies live, but the holes, the vast, empty pockets of air within the sponge, those are the voids in our universe. These holes account for approximately 80% of the total volume. 80%, think about that number. It means that the overwhelming majority of reality is not filled with stars, or planets, or life. It is filled with the void. We live on the thin, fragile threads of matter, looking out across bubbles of darkness so large that they make our entire local group, look like a microscopic speck. The most famous of these is the Boötes Void, often called the Great Nothing. It was discovered in 1981, and it remains one of the most unsettling places in the cosmos. The Boötes Void is a roughly spherical region of space, approximately 330 million light-years in diameter. It is so large and so empty that it defies every human instinct for scale. To put this in perspective, remember that the distance to Andromeda is 2.5 million light-years. The Boötes Void is over 100 times wider than that gap. It is a region of space so vast that it could swallow thousands upon thousands of Milky Way galaxies and still appear empty. If you were placed at the center of the Boötes Void, you would experience a loneliness that no human being has ever known in any other part of the universe. Even in the intergalactic medium, you can look out and see the distant glow of other galaxies, but in the center of the Great Nothing, the sky would be black, truly, deeply black. There would be no stars, no hazes, no smudges of light, in a volume of space where the cosmic average would predict roughly 2,000 galaxies. Astronomers have found only 60 in a space that spans hundreds of millions of light years. Imagine, for a moment, a civilization arising on a planet, orbiting a star, in a galaxy at the very center of the Boötes Void. Their experience of the universe would be fundamentally different from ours. For most of human history, we have looked up and seen the stars of the Milky Way, and beyond them, the faint light of other galaxies. But for the inhabitants of the void, there would be nothing beyond their own stars. They would look out into the night and see an endless, featureless abyss. They would have no reason to believe that other galaxies even existed. Their scientists would look at the sky and conclude that their galaxy was the only thing in the entire universe. The revolution in astronomy that occurred on Earth in the early 20th century, when Edwin Hubble proved that the universe was full of other island universes, would never have happened there. The inhabitants of the Boötes Void would be intellectually isolated, trapped by the emptiness of their surroundings. They would live in a state of cosmic solitary confinement, never knowing that they were part of a vast, glittering web of trillions of galaxies. It is estimated that they would not have discovered the existence of the rest of the universe until the 1960s, when their telescope technology became powerful enough to peer across the hundreds of millions of light-years of nothingness to the distant shores of the nearest filament. The void would not just isolate them physically, it would hide the very truth of reality from them. But why do these voids exist? Why is the universe not filled evenly with galaxies? The answer lies in the earliest moments of the Big Bang. In the infant universe, matter was distributed almost perfectly, but not quite. There were tiny, microscopic ripples in the density of space. Over billions of years, gravity took those tiny ripples and amplified them. Regions with slightly more matter pulled in more material, growing denser and forming the filaments where we live. But the regions with slightly less matter were slowly drained. Their material was pulled away by the stronger gravity of the surrounding filaments, leaving behind these enormous, expanding bubbles of nothing. The voids are the negative space of the cosmos. They are the regions that lost the gravitational tug-of-war, and because they are so empty, they are expanding faster than the rest of the universe. Dark energy, the mysterious force driving the expansion of space-time, has no gravity to resist it inside these bubbles. As a result, the voids are growing. They are pushing the filaments apart, stretching the threads of the cosmic web, and making the universe emptier with every passing second. The isolation we feel today is a direct result of these voids winning the battle for the cosmos. The few galaxies that do exist inside the Boötes Void are among the loneliest objects in existence. Often called void galaxies, they are small, isolated, and slowly evolving, without the collisions and mergers that happen in denser environments. These galaxies drift through the darkness in a state of cosmic stasis. They have no neighbors to interact with, no tidal forces to trigger the birth of new stars. They are like ghost ships, sailing across a lightless ocean, with no port and no destination. They are a reminder that in the grand architecture of the universe, structure is the exception, and the void is the rule. When we look at a map of the universe, we tend to focus on the bright spots. We name the clusters, we map the filaments, we obsess over the light, but the real story of the universe is the darkness between them. The real distance between galaxies is defined by these enormous bubbles of nothing. We are perched on the edge of an abyss, looking across gaps that light itself takes hundreds of millions of years to cross, and inside those gaps there is no matter, no energy, and no hope of connection. As you sit in the silence, try to visualize yourself standing on the shore of a great void. Behind you is the warmth and light of the cosmic web. Ahead of you is 300 million light-years of absolute, featureless black. No matter how long you wait, no matter how powerful your telescope, you will never see a single point of light in that direction. It is a desert that has no end, a silence that has no bottom. This is the 80% of the universe that we rarely speak of. This is the reality of the intergalactic wasteland. In the next chapter, we will look at the threads that hold these bubbles together. We will explore the cosmic web, the vast scaffolding of dark matter that connects the galaxies across the voids. But even as we look at the connections, we will find that they are fragile, that the web is stretching, and that the voids, in the end, will be all that remains. Settle deeper now. The darkness of the Boötes Void is surrounding us. The light is a distant memory, and in this great, unyielding nothing, we find the true scale of our isolation. The great nothing is not just a place. It is the future of the cosmos. Stay with me as we move from the bubbles to the threads. We have spent much of our journey exploring the gaps, the vast, terrifying bubbles of nothing that define 80% of the universe. But now, we must look at the threads that keep the cosmos from falling apart entirely. We must look at the architecture of the light. Astronomers call it the cosmic web. It is the largest structure in existence, a sprawling, three-dimensional network of gas and dark matter that spans the entire observable universe. If you could zoom out far enough, past the galaxies, past the clusters, past even the great voids, you would see that the universe is not a chaotic mess. It is organized. It is a gossamer lattice, a delicate, luminous foam, where every galaxy is a dewdrop caught on a strand of invisible silk. This is the scaffolding of reality, the blueprint that gravity has been writing for 13 billion years. But to see the web, you must first understand that most of it is invisible. The galaxies we have been discussing, the Milky Way, Andromeda, the trillion sun empires, are not the architects of this structure. They are merely the occupants. They are the bright glowing ornaments hanging on a much larger, darker frame. This frame is made of dark matter. It is a substance that does not emit light, does not reflect it, and does not absorb it. It is a phantom material that outweighs ordinary matter by a ratio of 5:1. We cannot see it. We cannot touch it. But we can feel its weight. It is the gravitational anchor of the universe. Without dark matter, the galaxies would fly apart. Without dark matter, the cosmic web would dissolve into a featureless haze. It is the invisible architect of the isolation, the force that pulled matter out of the voids and wove it into the thin, fragile threads where we now live. Imagine a vast, dark ocean, and on the surface of that ocean, there are thin ribbons of glowing foam. These ribbons are the filaments. They are the primary components of the cosmic web. A typical filament can stretch for hundreds of millions of light years, yet it is remarkably thin compared to its length. These are the highways of the cosmos. They are composed of dark matter and a thin, hot gas, and they serve as gravitational conduits. Galaxies do not just sit still in the dark. They are channeled along these filaments, slowly drifting toward the dense intersections where multiple threads meet. Our own Milky Way is part of such a filament, a narrow ridge of structure perched on the edge of the local void. We are traveling along a road that was built before the Earth existed, moving toward a destination we will never reach, at a speed that barely registers against the scale of the journey. When you look at a simulation of the cosmic web, it looks like a neural network. It looks like the neurons in a human brain or the roots of an ancient forest. There is a profound sense of connection in this image. It suggests that the universe is a single, unified organism, where every part is linked to every other part by these grand, sweeping threads. But this is where the lie of the photograph returns to haunt us, because while the filaments are real, and the connections are gravitational, the distances involved are still absolute. A single filament might be 50 million light-years long. The galaxies along that thread might be millions of light-years apart. To call it a web implies a level of intimacy that the universe simply does not possess. It is a web where the threads are so long, and the travel time is so vast, that a vibration on one side of the structure will never be felt on the other. It is a connection in name only. Where the filaments intersect, they form the nodes. These are the cities of the universe, galaxy clusters, the Virgo cluster, the Coma cluster, the Great Attractor. These are regions where thousands of galaxies are packed together in a space only a few million light-years wide. Here, the isolation feels less absolute. In a cluster, galaxies collide. They tear stars from one another. They merge and grow. There is a sense of cosmic activity, a bustling metropolis of light. But even here, in the densest regions of the cosmic web, the voids are never far away. The clusters are merely the intersections, the brief, crowded moments in a universe that is otherwise defined by the gaps. And even the clusters are not static. They are being pulled and stretched by the implacable growth of the voids on either side of them. The cosmic web is not a permanent monument. It is a transient phase. It is a fragile arrangement of matter that exists only because gravity and expansion are currently in a state of uneasy balance. But that balance is shifting. Dark energy, the force that lives in the empty spaces, is pushing back. It is stretching the filaments. It is making the threads thinner and longer. As the voids expand, they are pulling on the web, like a hand pulling on a piece of fabric until the threads begin to snap. The connections that currently bind the universe together are being tested. In the deep future, the filaments will stretch so thin that they will disappear. The gas will become too diffuse to form new stars. The bridges between clusters will break, and each node, each cluster of galaxies, will find itself alone in an infinite, expanding dark. Think about the fragility of our own position. We are part of the Laniakea supercluster, a vast continent of the cosmic web that contains 100,000 galaxies. It is a beautiful name, Laniakea, which means immeasurable heaven. But even this immeasurable heaven is not a bound structure. It is a flow. Every galaxy in Laniakea is moving toward a central point called the Great Attractor. But the expansion of space is faster than the pull of gravity. Laniakea is not coming together. It is being pulled apart. The continent we belong to is dissolving. The threads that connect us to the Virgo cluster are fraying. We are watching the slow, silent disintegration of the largest structures we have ever mapped. The web is unraveling, and we are clinging to one of the final threads. This is the deeper reality of the cosmic web. It is a structure built on the edge of an abyss. It is a network of highways that lead to nowhere. We see the filaments, and we see the nodes. And we feel a sense of grand design, but the design is temporary. It is a brief moment of organization in a universe that is trending toward total disorder. The web is the universe's last attempt to hold itself together, before the expansion of space carries every island of light beyond the reach of every other. We live in the golden age of the web, a time when the threads are still visible, and the connections can still be mapped. We are the last generation of observers who can see the full architecture of the light before the voids consume the frame. As you settle deeper into the silence, try to visualize that web. Don't see it as a static map. See it as a living, breathing thing. See the filaments as long, glowing ribbons, gently swaying in the gravitational tide. See the galaxies as tiny, shimmering dewdrops, caught in a structure that is far larger and far more ancient than they are, and then feel the stretch, feel the slow, relentless expansion of the voids, pulling on those ribbons, making the connections thinner, making the distances longer. Feel the fragility of the light. We are part of a structure that is as beautiful as it is temporary. We are dewdrops on a web, and the morning sun of cosmic expansion is rising to dry the threads. In the next chapter, we will look at the force that is doing the pulling. We will look at dark energy, the mysterious, invisible energy of the vacuum itself. We will see why the distance is not just a gap, but an active, growing barrier. We will see why the web is doomed to snap, and what the universe will look like when the last thread is gone. Settle in as we move from the scaffolding to the force that is tearing it down. The threads are thinning, the gaps are winning, and the silence is only getting deeper. Stay with me as we face the great divider. We have mapped the threads of the cosmic web, and we have looked into the dark, silent voids that they surround. But now, we must face the most disturbing truth of all. The distance between galaxies is not a fixed number. It is not a static gap that we can simply measure once and move on. It is a growing wound. The universe is not just large. It is actively, relentlessly getting larger. And the reason for this is a force so mysterious, so pervasive, and so terrifyingly powerful that it currently dominates the fate of everything in existence. Astronomers call it dark energy. It is the great divider, the invisible engine of the void, and it is the reason why the isolation we have discussed tonight is not just a condition, but a destiny. To understand dark energy, you must first change how you think about space itself. Most of us imagine space as a container, a vast empty stage where stars and galaxies perform their dance. We think of it as nothingness, a vacuum that simply exists to hold the matter within it. But Einstein taught us that space is not a passive stage. It is a fabric. It is a physical thing, with its own properties, its own geometry, and its own energy. And one of the most shocking discoveries in the history of science is that space does not like to be compressed. In fact, space wants to expand. Every cubic meter of the vacuum possesses a tiny intrinsic amount of energy. It is as if the nothingness itself has a cost, a hidden pressure that pushes outward in every direction. And because the universe is so vast, this tiny pressure from every empty patch of space adds up to a force that is now literally tearing the cosmos apart. For most of the 20th century, astronomers believed that the expansion of the universe was slowing down. They assumed that the gravity of all the trillions of galaxies would eventually act like a brake, pulling back on the expansion that began with the Big Bang. They thought that one day, the universe might even stop expanding and begin to collapse back in on itself. But in 1998, the world of science was shattered. Observations of distant supernovae revealed that the expansion is not slowing down at all. It is accelerating. The galaxies are not just moving away from us. They are flying away faster and faster with every passing second. Something is overpowering gravity. Something is pushing the universe apart at an ever-increasing rate. That something is dark energy, and it makes up approximately 70% of the entire universe. This is why the distance between galaxies is worse than you think. It is not just that the gaps are large. It is that the gaps are actively creating more gap. Think of it this way. Imagine you are standing on a giant sheet of rubber, and another person is standing a mile away from you. If you both stay still, the distance remains 1 mile, but now, imagine that the rubber itself is stretching. Every inch of that rubber is growing, becoming 2 inches, then 3, even if you don't move your feet. The distance between you and the other person grows. This is what is happening to the universe. Galaxies are not flying through space like bullets. Space itself is growing between them. Every light year of empty intergalactic void is producing more light years. A relentless, automated factory of emptiness that never shuts down. The horror of dark energy lies in its relationship with volume. Gravity gets weaker as things move apart. If you double the distance between two galaxies, their gravitational pull on each other drops to 1/4 of what it was, but dark energy, because it is a property of space itself, does not get weaker. In fact, it gets stronger. The more space there is, the more dark energy there is, and the more dark energy there is, the faster the space expands. Which in turn creates even more asterisk space. It is a runaway feedback loop of isolation. Gravity, the force that builds stars and brings worlds together, is a local power. It wins on the scale of solar systems and galaxies, but on the scale of the intergalactic void, dark energy is the undisputed king. It has already won the battle. It has taken the vastness we have discussed tonight and turned it into an escalating separation that nothing can stop. Think about what this means for our future. Because the expansion is accelerating, there is a limit to how much of the universe we can ever see or reach. Astronomers call this the cosmic event horizon. It is a boundary in space beyond which the expansion is so fast that even light can never cross the gap. Imagine a galaxy 10 billion light years away. If that galaxy is receding from us faster than the speed of light, not because it is moving through space, but because the space itself is stretching too fast, then any light that galaxy emits today will never, ever reach us. It is as if a door has been slammed shut between us and the rest of reality. We can see the light that galaxy sent billions of years ago, but its present self is already gone. It has moved beyond the horizon of reachability. It has become a ghost, a fossil, a part of a universe that is no longer connected to ours. Current estimates are devastating. Of the 2 trillion galaxies in the observable universe, it is believed that 94% are already beyond our reach. Even if we could build a ship that traveled at the speed of light, and even if we launched that ship this very second, we could only ever reach 6% of the galaxies we see in our telescopes. The other 1.9 trillion galaxies are already lost. They are receding too fast. The rubber sheet of space is stretching between us and them at a velocity that light cannot overcome. They are part of the untouchable universe. We can watch them, we can study their past, but they are forever sealed away in a separate bubble of spacetime. Dark energy has partitioned the cosmos, turning it from a unified web into a series of isolated cells, and the walls between those cells are growing thicker every moment. As the eons pass, dark energy will continue its work. It will pull the galaxy clusters apart. It will stretch the filaments of the cosmic web until they snap. Eventually, it will carry every other galaxy, every other cluster, and every other supercluster beyond our horizon, the Virgo cluster, which currently sits 54 million light years away, will drift further and further, its light red shifting and fading, until it vanishes from our sky. One by one, the campfires of the other galaxies will go out, not because the stars have died, but because the space between us has become an infinite, impassable wall. We will be left in a universe that appears to contain nothing but our own local group. The Great Divider will have completed its task, leaving us in a state of ultimate, irreversible isolation. There is a cold, mathematical cruelty to this force. It does not hate us. It does not even know we exist. It is simply a fundamental property of the vacuum, but its effect is to dismantle the connections that gravity spent billions of years building. It is the anti-gravity, the force of unbuilding. It ensures that the story of the universe ends in a great freeze. a state where every island of matter is so far from every other that the concept of a universe loses all meaning. There will only be the here and an infinite growing elsewhere that can never be known. Dark energy is the reason why the distance is worse. It is the reason why the isolation is not just a tragedy of scale, but a law of physics. As you drift closer to sleep, or as you sit in the deepening silence, try to feel that stretch. Don't think of space as a static void. Think of it as a living, growing thing. Every second, the space in the room around you is trying to expand. But the gravity of the earth and the chemical bonds of your own body are too strong. They hold you together. But out there, in the dark, between the Milky Way and Andromeda, there is nothing to hold the fabric back. The stretch is winning, the distance is growing, and the great divider is silently, patiently, pulling the stars away from each other, until the very idea of a neighbor becomes a myth from a forgotten age. In the next chapter, we will look at what happens when we try to fight this force. We will look at the physics of travel, and why even our most ambitious dreams of near light speed flight are crushed by the cold reality of intergalactic scale. We will see why relativity is not just a theory, but a final, unyielding lock on the door of our prison. Settle in as we move from the force that divides us to the laws that keep us trapped. The horizon is closing, the light is stretching, and the silence is just beginning to take hold. Stay with me as we face the impossible journey. We have looked at the forces that build the universe and the dark energy that is now tearing it apart. And it is here, in the shadow of these staggering realities, that we often find ourselves reaching for a hope. We look to the future. We look to the brilliance of human ingenuity. We imagine a day when our technology will finally bridge the gaps, when our engines will become powerful enough and our ships fast enough to conquer the intergalactic silence. We grew up on stories of warp drives, wormholes, starships that jump across the light years in a heartbeat. We have been taught by our fiction that distance is merely a technical hurdle, a problem awaiting an engineering solution. But as we step into the cold reality of physics, we find that the laws of the universe do not care about our ambition. Relativity, the very framework of space and time, is not a bridge, it is a lock, and the door it has closed is one that no engine, no matter how powerful, was ever meant to open. Think about what it truly takes to move through the void. In our world, we are used to the idea that if we want to go faster, we simply need more fuel or a better engine. We assume that velocity is a linear climb, that with enough energy, we can push ourselves as close to the speed of light as we desire. But the universe has a hidden tax on speed. As an object approaches the speed limit of light, it begins to change. Einstein's equations tell us that mass and energy are two sides of the same coin. As you add energy to a spacecraft to make it move faster, that energy does not just increase the speed, it also increases the mass of the ship. At 90% of the speed of light, the ship becomes a heavy, sluggish titan, requiring even more energy to push it just a fraction faster. The closer you get to the ultimate limit, the heavier the ship becomes, until the energy required to reach the speed of light itself becomes infinite. You could consume every star in the Milky Way. You could turn the entire mass of a galaxy into fuel, and you would still never reach that final, elusive barrier. But let us be generous. Let us imagine a civilization that has achieved the impossible, a society that has harnessed the total energy output of its sun and built a ship capable of traveling at 99.9% of the speed of light. To us, this is a godlike achievement, a vessel moving so fast that it could cross the solar system in minutes. If we pointed this ship toward the Andromeda galaxy, we might imagine that the journey would finally be manageable. And here, the universe reveals its most haunting trick. It is called time dilation. It is a consequence of relativity that ensures that the faster you move through space, the slower you move through time. For the crew on board that ship, The 2.5 million light-years to Andromeda would not feel like millions of years. Because of the extreme velocity, time for them would stretch. To the astronauts, the journey might only feel like 50 years. They would live to see the other shore. They would survive the transit. But there is a devastating price to be paid for this shortcut through time. While only 50 years have passed for the crew, 2.5 million years have passed for the planet they left behind. This is the relativistic trap. If you leave Earth today to visit our nearest neighbor at near light speed, everyone you have ever known, every city you have ever walked in, and every trace of the civilization that launched you will be gone long before you even reach the halfway point. You would arrive at Andromeda as a ghost from a forgotten era, reporting back to a home that has been silent for millions of years. The distance does not just separate locations, it severs the continuity of history. Intergalactic travel is not a journey from one place to another. It is a one-way trip to the end of your species' timeline. You can cross the gap, but you can never go home, not because the engines won't take you back, but because home no longer exists in the era you now inhabit. The energy required for such a journey is almost beyond the ability of language to describe. To accelerate even a modest spacecraft to 90% of the speed of light, you would need energy quantities that dwarf the total output of human civilization for its entire history. You are not just burning fuel, you are attempting to move a mountain at the speed of a photon. The kinetic energy of such a ship would be so great that hitting a single, microscopic grain of dust in the intergalactic void would result in an explosion equivalent to a nuclear weapon. The void, which we have described as empty, becomes a minefield when you travel at relativistic speeds. A single hydrogen atom, striking the hull of a ship moving near the speed of light, becomes a burst of lethal radiation. To survive the crossing, the ship would need shields of such immense power and mass that the energy required to move them triples. The physics itself conspires against the traveler. The universe is not just big, it is structurally resistant to being crossed. There is the problem of the destination. If we launched a ship today toward a galaxy in the Virgo cluster, 54 million light-years away, the expansion of space-time would act as a headwind. Every year the ship travels, dark energy is creating more space between the ship and its goal. It is like trying to run on a treadmill that is slowly, but surely, speeding up for the most distant galaxies, the ones near the edge of our observable horizon. No engine is fast enough. Even at the speed of light, the expansion of space is creating new distance faster than the ship can cross it. We are like prisoners in a cell where the walls are moving outward faster than we can run toward them. No breakthrough in physics, no matter how revolutionary, can change the fact that the fabric of the universe is working against us. We are not just fighting distance, we are fighting the growth of reality itself. This is why the distance between galaxies is worse. It is a barrier that is baked into the very math of existence. We often dream of wormholes, shortcuts through the fabric of space that would allow us to bypass the millions of light years in an instant. But even if such things are possible, the energy required to hold one open, the stability required to traverse one, and the sheer mathematical improbability of finding one, suggest that they are not a practical solution for a physical species. We are biological creatures, built for a world of slow speeds and short distances. Our lives are measured in decades, but the universe is measured in eons. We are trying to understand a symphony that lasts 1 billion years, using an instrument that only plays for a second. The mismatch between our scale and the cosmic scale is the ultimate tragedy of our existence. Think about the silence of that ship, crossing the void between the Milky Way and Andromeda. Even at 99% of the speed of light, the stars would not zip past you like they do in the movies. The stars are so far away, and the gap is so empty, that for centuries, it would appear as though you were not moving at all. You would be suspended in a frozen, lightless eternity. The ship's instruments would confirm your speed, but your eyes would see only a static, unchanging darkness. You would be a prisoner in a metal box, hurtling through a vacuum that has no landmarks, no milestones, and no end. The psychological weight of that isolation, the realization that everyone you ever loved is already a million years dead, would be a burden heavier than the ship itself. As we drift deeper into the night, we must accept the cold comfort of the truth. The engines will not save us. The technology will not bridge the gap. We are part of a universe that has a speed limit, and that limit is the final, unyielding guardian of our isolation. The Milky Way is our home. And for all intents and purposes, it is our only home. The galaxies we see in the distance are not destinations. They are scenery, they are beautiful, glowing reminders of what lies beyond reach. They are the untouchables. And as we move into the next chapter, we will look at the finality of this boundary. We will see why 94% of the universe is already lost to us, and what it feels like to live in a bubble of light, in a cosmos that is closing its doors. Settle in. As we face the cosmic event horizon, the light is fading, the engine is silent, and the distance is winning. Stay with me as we look at the galaxies we have already lost. We have looked at the distances, and we have confronted the limitations of our own technology, but now we must face the most heartbreaking realization in all of cosmology, a truth so vast and so final that it redefines our place in the universe. We often speak of the observable universe, the grand sphere of space reaching out 46 billion light-years in every direction. This is the limit of what we can see. It contains an estimated 2 trillion galaxies, each one a city of stars, but there is a second, much smaller boundary that we rarely discuss. It is called the cosmic event horizon, and it is the limit of what we can ever, truly, touch. If the observable universe is a vast library of trillions of books, the event horizon is the realization that 94% of those books are already behind a locked glass case. We can see the titles. We can admire the covers, but we will never, ever be able to open them. This is the tragedy of an expanding cosmos, because light takes time to travel. When we look deep into space, we are looking deep into the past. We see galaxies as they were billions of years ago, but while that light was making its long, lonely journey toward Earth, the space between us and those galaxies was stretching. Dark energy has been pushing the universe apart for eons, and for the vast majority of the galaxies we see, that expansion has already carried them too far away. Current calculations suggest that if you were to leave Earth today in a ship traveling at the speed of light, you would only be able to reach about 6% of the galaxies in the observable universe. The other 94%, roughly 1.9 trillion galaxies, are already beyond our reach. They are receding from us faster than light can cross the gap, not because they are moving through space, but because the fabric of space-time itself is growing too fast. They are visible fossils, but physically, they are already in a different universe. Imagine standing on a platform, watching a train pull away. As long as the train is moving slowly, you could run and catch it, but this train is accelerating, and there comes a point, a specific, mathematical moment where the train is moving so fast that no matter how hard you run, no matter how much energy you expend, you will never reach the door. You can still see the passengers waving from the window. You can see the light reflecting off the metal, but the connection is severed. This is the state of our universe. 1.9 trillion galaxies have already missed the train. Their light is still arriving at our telescopes, a ghostly record of where they were 10 billion years ago, but where they are now, in the present tense, is a place that we can never, ever visit. They have crossed the horizon. They have entered the untouchable universe. Think about the scale of that loss. 1.9 trillion galaxies, each one containing hundreds of billions of suns, each one hosting untold trillions of planets. We are looking at a sky filled with trillions of potential civilizations, trillions of beautiful, complex worlds, and every single one of them is already gone. Astronomers in a museum, looking at the fossilized remains of a cosmos that was once connected, but is now shattered into a billion isolated shards. When you look at the Hubble Deep Field, and you see those thousands of tiny glowing dots, remember that nearly every single one of them is an illusion. They are ghosts. If you launched a signal toward them today, it would never arrive. It would travel through the dark forever, chasing a target that is receding faster than the signal can fly. The distance has become infinite, not in miles, but in the possibility of contact. This is why the distance between galaxies is the most terrifying reality we know. It is not just a gap. It is a closing door. We happen to live in a very brief, very privileged moment in cosmic history. We live in an era where the light from these distant empires is still reaching us. If we had been born 100 billion years later, the expansion of the universe would have carried all those galaxies so far away that their light would be too faint to see. Future astronomers would look out at the sky and see only blackness. They would never know that 2 trillion galaxies once filled their heavens. They would think they were alone in an infinite, empty void. We are the last generation of observers who can see the true scale of the cosmos, and yet, we are also the generation that has discovered we can never touch it. The cosmic event horizon is not a wall of fire or a physical barrier. It is a mathematical line in the sand, drawn by the expansion of space-time, and it is shrinking every second. The volume of the universe that we can reach gets smaller. Every moment, millions of stars are crossing that line, slipping away from us forever. It is as if we are on a small island, and the tide is rising. One by one, the distant landmarks are being swallowed by the dark water. We can still see the lights on the far shore, but we know the bridge is gone. We are witnessing the slow, silent partitioning of reality. The universe is being dismantled, galaxy by galaxy, and there is no force in physics that can stop the unraveling. Consider the loneliness of this perspective. We look out at a universe that appears crowded and vibrant, but we are actually living in a bubble of isolation that is only 6% of the total. We are trapped in a local neighborhood, a small collection of galaxies called the local group, which is gravitationally bound together. This is our reachable universe. Everything else, the vast superclusters, the glowing filaments of the cosmic web, the trillions of islands of light, is leaving us. They are not just far away. They are functionally in another dimension of existence. We can observe them, but we can never influence them. We can study them, but we can never join them. We are spectators at a play where the actors are a billion miles away, and the curtain is slowly, but surely, coming down. As you lie here in the silence, try to visualize those 1.9 trillion galaxies. Don't see them as abstract points of light. See them as real places. Imagine the sunsets on a trillion different worlds. Imagine the civilizations that may be rising and falling, the art they are creating, the questions they are asking, and then feel the horizon. Feel the stretching of space that keeps us forever apart. We are all inhabitants of the same universe, but we are separated by a gulf so absolute that even the speed of light is not fast enough to bridge it. The distance has become a finality, a sentence of eternal solitude. We often think of the end of the universe as something that will happen in the far, far future, but for 94% of the cosmos, the end has already happened. The connection has been broken. The light we see is just a lingering echo, a beautiful, haunting reminder of a time when the universe was smaller and the horizons were wider. As we move into the next chapter, we will look at our own neighborhood. We will look at the few galaxies that asterisk are still within our reach, and the violent, beautiful merger that awaits them. But we do so with the knowledge that we are the lucky ones. We are the ones who can still see the ghosts before they vanish. Settle deeper now. The event horizon is behind us. The untouchable trillions are fading into the dark, and we are returning to the only home we have ever known, a small cluster of light in an ocean of infinite, expanding silence. Stay with me as we face the reunion of the ghosts. So, we have looked at the trillions of galaxies we have already lost. We have felt the weight of the 94% of the cosmos that is forever beyond our reach. But now, let us return to the only neighborhood we have left. Let us look at the few islands of light that are still within our circle of warmth. This is the local group, a small, gravitationally bound family of about 130 galaxies. Here, gravity has managed to do the impossible. It has fought the expansion of space-time to a standstill. Within this small bubble, the galaxies are not flying apart. They are being pulled together, and at the heart of this family drama are two titans, the Milky Way and Andromeda. They are currently falling toward each other at 250,000 miles per hour, and in this final movement of our cosmic story, we are witnessing a bitter reunion. A slow, gravitational dance that will eventually end in the birth of a new empire. Think about the irony of this collision. We spent the earlier chapters discussing how far apart these two galaxies are, how light itself needs 2.5 million years to bridge the gap. We looked at the 4 billion year journey it would take for our fastest probes to cross the wasteland, and yet, on the scale of the universe, these two are already touching. They are locked in a mutual embrace that has been tightening for billions of years. Gravity is the invisible thread that connects them. A tether that dark energy cannot snap. They are destined to meet. In roughly 4 to 6 billion years, the Milky Way and Andromeda will begin the violent, beautiful process of merging into a single structure. We have already given it a name, Milkomeda. But do not imagine a collision in the way we understand it on Earth. When we think of a collision, we think of impact. We think of two cars smashing together, metal twisting, energy releasing in a sudden, violent burst. But galaxies, as we have learned, are mostly made of nothing. They are vast, empty spaces punctuated by the occasional star. When the Milky Way and Andromeda finally meet, it will be a collision of ghosts. The distances between individual stars are so enormous that it is estimated that out of the 1.4 trillion stars involved in this merger, almost none of them will actually hit each other. You could fire 1 billion bullets at a swarm of bees from a mile away and likely never hit a single one. This is the scale of the merger. The stars will simply pass through the gaps, drifting past one another like dancers in a darkened ballroom. However, while the stars themselves may never touch, their gravity will tear the galaxies apart. As Andromeda approaches, its massive gravitational field will begin to pull at the spiral arms of the Milky Way. Our sky will transform. If there are still eyes on Earth to see it, they will look up and see a second, ghostly river of light approaching our own, over millions of years. The elegant spirals we see today will be shredded. Gas clouds will slam into each other, triggering the birth of millions of new stars. A final, frantic burst of creation before the two structures settle into their new shape. The black holes at the center of each galaxy, our Sagittarius A star and Andromeda's massive core, will begin an orbital dance, eventually spiraling inward until they merge into a single, terrifying titan of gravity. This merger is a bitter reunion because it is the final act of our local history. By the time Milkomeda is fully formed, the sun will have already reached the end of its life. It will have grown into a red giant, swallowed the inner planets, and faded into a white dwarf. The Earth as we know it will be long gone. But the galaxy that replaces our home will be a magnificent, glowing elliptical structure. It will no longer have the beautiful, thin spiral arms we see in our telescopes today. It will be a vast, rounded swarm of 1 trillion stars, a stable, permanent empire of light, but it will be an empire with no neighbors. This is the deeper tragedy of the Milkomeda merger. While our local galaxies are coming together, the rest of the universe is being pushed away. Dark energy is continuing its relentless work. By the time the Milky Way and Andromeda have finished their merger, Every other galaxy cluster in the observable universe will have receded beyond our reach. The Virgo cluster, the Laniakea supercluster, the trillions of islands we have discussed tonight will all be gone. They will have crossed the cosmic event horizon, vanishing into the untouchable dark. Milkomeda will be the only thing left. We will have finally achieved a perfect union with our neighbor, only to find that the rest of the cosmos has abandoned us. Imagine a civilization arising on a planet orbiting a star in the deep future of Milkomeda. They would look out at the sky and see 1 trillion stars. Their galaxy would be vibrant, full of light, and seemingly infinite. But when they pointed their telescopes past the edge of those stars, they would see nothing, not a single other galaxy. No cosmic web, no filaments, just a black, featureless abyss stretching to the end of time. They would have no evidence that a Big Bang ever happened. They would have no way of knowing that 2 trillion other galaxies once shared their universe. They would believe, with absolute scientific certainty, that their galaxy was the only thing in existence. They would be the ultimate victims of the intergalactic distance. The Milkomeda merger is the universe's way of tidying up. It is the final consolidation of matter before the great silence takes over. It is a reunion of 2 long-lost sisters, meeting in a house where all the other lights have already been turned off. We are falling toward Andromeda because gravity is trying to save us from the void, but it can only save so much. It can hold on to our local group, but it cannot hold on to the rest of reality. We are witnessing the slow, silent contraction of our reachable world, even as our local world grows larger through this merger. As you settle into the deepest part of the night, try to visualize that future sky. See the 2 great spirals, the Milky Way and Andromeda, slowly drifting into one another. See the stars passing like ghosts through the emptiness. And then, see the darkness beyond. We are part of a story that ends in a single massive, isolated city of stars, a city that will burn for trillions of years, but will never see another light on the horizon. The distance between galaxies has finally become infinite. The separation has become absolute. We are becoming Milkomeda, the final island, in a universe that has become a single, unyielding void. In the next chapter, we will look at this final state. We will explore the final loneliness, the era when the sky goes black, and the last traces of the cosmic story are erased. We will see what it means to live at the end of history, and why we, in this moment, are the luckiest observers the universe will ever produce. Settle in as we leave the merger behind and face the eternal darkness. The reunion is over, the doors are locked, and the silence is nearly complete. Stay with me for the final reckoning. Imagine a world 100 billion years from now, a world orbiting a quiet, long-lived star. In the far reaches of the galaxy we now call Milkomeda, the inhabitants of this world look up at their night sky, and they see a spectacular river of stars, 1 trillion suns, glowing with the steady light of an ancient, stable empire. To them, the universe looks full, it looks permanent, it looks complete. But as they point their most powerful telescopes toward the great beyond, past the edge of their own galactic stars, they find something that defies all reason. They find nothing, not a single other galaxy, not a single cluster, not a single smudge of light in the infinite. Unyielding black, they are the inhabitants of the final loneliness. And they are living in a universe that has successfully erased its own history. This is the ultimate consequence of the intergalactic distance. It is the end point of the expansion we have discussed tonight. Dark energy, the invisible engine of the void, will eventually complete its task of dismantling the cosmic web. One by one, the distant superclusters have crossed the cosmic event horizon. One by one, the bridges of light that once connected the heavens have snapped. The Virgo cluster, Laniakea, the trillion islands of the observable universe, they are all gone. They have moved so far away and are receding so fast that their light can no longer reach this future world. The distance between galaxies has finally become so vast that it has turned into an absolute, impassable wall of darkness. Think about the profound tragedy of this future civilization. Their scientists would be as brilliant as ours. Their mathematics would be flawless. Their telescopes would be masterpieces of engineering. But they would be trapped in a lie, because the universe has expanded so much. The evidence for the Big Bang would be gone. The cosmic microwave background, the faint afterglow of creation that we can still see today, would have faded into a whisper so thin and so stretched that no instrument could ever detect it. The red shift of distant galaxies, which taught us that the universe is expanding, would be an impossible observation, because there are no distant galaxies left to see. They would look at their lonely galaxy, sitting in an infinite, empty void, and they would conclude that it has existed forever, unchanging and alone. They would have no way of knowing that the universe once contained 2 trillion galaxies. They would have no way of knowing that space was once a vibrant, interconnected web of matter. Their cosmology would be perfectly logical, and yet it would be fundamentally wrong, not because of a failure of their minds, but because the universe is a place that hides its tracks. It is a cosmos that grants a brief window of self-awareness, and then slowly, relentlessly, closes the shutters. These future observers are the prisoners of a perfect vacuum, living in a reality that has been stripped of its context. They are the final children of the light, born into a darkness that offers no clues about where it came from. This is the worse than you think reality of the cosmic scale. It doesn't just isolate us in space, it isolates us in time. We often think of ourselves as small and insignificant in the face of 2 trillion galaxies, and in many ways, we are, but we are also the most privileged observers the universe will ever produce. We happen to live in the golden age of cosmology. We live at a time when the universe is old enough to have formed complex structures like us, but young enough that the evidence of its birth is still visible. We can see the other islands. We can measure the expansion. We can reconstruct the entire story of the last 13.8 billion years. We are the ones who get to see the full architecture of the light, before the great divider tears it all down. As you drift closer to the edge of sleep, try to feel the weight of that privilege. Every time you look at a photograph of a distant galaxy, you're seeing something that will one day be impossible to see. You are witnessing a connection that is currently being severed. The 2.5 million light-years to Andromeda, the 54 million light-years to Virgo. These are the final threads of a conversation that is ending. We are the ones who can still hear the music, before the silence becomes total. The distance is not just a number, it is a countdown. And we are living in the final minutes of the cosmic morning. In this final loneliness, the concept of distance itself begins to lose its meaning. If there is nothing else in the universe to measure against, how do you know how large the void truly is, if there are no other landmarks? How do you know you are moving? The inhabitants of the deep future will live in a universe that is functionally static, a single massive, isolated city of stars, surrounded by an abyss that has no far shore. To them, the idea that there was once a distance between galaxies would sound like a myth, a fairy tale from a time when the universe was small enough to be crowded. They will never know the terror of the voids we have discussed tonight, because for them, the entire universe will be one, single, infinite void. There is a haunting peace in this realization. The struggle of gravity against expansion, the violent mergers of galaxies, the frantic birth of stars in the cosmic web, all of that drama will eventually settle into a long, slow, quiet evening. The Milkomeda galaxy will burn for trillions of years. Its red dwarf stars will continue to glow, providing a steady, dim light for civilizations that will have no idea they are the last of their kind. They will live out their histories, build their monuments, and dream their dreams in a perfect, unyielding solitude. the silence we have explored tonight, the intergalactic silence, will be their only reality. We are the ones who feel the fear. We are the ones who can see the scale and realize our own isolation, but we are also the only ones who can appreciate the beauty of the web. We can see the filaments. We can see the nodes. We can see the great bubbles of the voids. We can see the 2 trillion campfires burning in the dark, and even if we can never reach them, even if we can never speak to them, even if we are already separated by a gulf that is growing faster than light, the fact that we can see them at all is a miracle. It is a brief, beautiful, and temporary gift from a universe that is in the process of dismantling itself. As the light in your own room grows dim, and as the world around you becomes quiet, think about our position in the timeline. We are the bridge. We are the ones who remember the crowded universe, and the ones who are beginning to see the coming dark. The distance between galaxies is the most terrifying reality in the cosmos, but it is also the most honest. It tells us that everything is temporary, that every connection is fragile, and that the light we see is a precious, fleeting echo of a past that is already leaving us. We are the observers of the vanishing, the witnesses of the great dispersal. The final loneliness is not just a chapter in a book. It is the destination of the universe. Every atom of hydrogen, every photon of light, and every second of time is leading us toward that absolute, featureless silence. But for now, the stars of the Milky Way are still here. Andromeda is still a visible smudge in the autumn sky. The Virgo cluster is still a detectable glow in our telescopes. The threads of the web are still holding. We are not yet alone. We are just beginning to understand how alone we will eventually be. Settle into the darkness now. Let the trillions of galaxies fade from your mind. Let the 1.9 trillion untouchable empires drift beyond your horizon. Return to the warmth of your own home, your own star, and your own breath. The universe is vast and empty and expanding, but here, in this moment, you are still connected to the light. The distance is worse than you think, but the fact that you can think about it at all is the greatest wonder of all. The journey through the void is over. The silence has arrived, and in the final chapter, we will find the peace that comes with the burden of being the ones who saw it all. Stay with me for the final, quiet goodbye. The sky is black, the fires are distant, and the void is finally at rest. Sleep now, in the heart of the only galaxy you will ever know. The final loneliness has already begun, and it is more beautiful and more silent than you could ever imagine. We have traveled across the inconceivable gulfs of space. We have felt the cold of the great voids, and we have watched the slow, relentless expansion of the darkness. We have seen the empires of stars, the trillions of islands of light, and we have come to understand the absolute, unyielding isolation that defines our reality. The journey has been long, the scale has been overwhelming, and now, as we return to the quiet of our own home, we are left with a final, haunting realization. We are the observers. We are the ones who happen to exist in the brief, beautiful window of time when the universe is still willing to reveal itself. We carry the burden and the privilege of being the witnesses to a cosmos that is slowly closing its doors. Think about the billions of years that came before us, and the trillions of years that will follow. For the vast majority of cosmic time, the story we have told tonight would be impossible to discover. In the early moments after the Big Bang, the universe was too hot and too dense for stars to shine, and in the deep future, it will be too empty and too dark for galaxies to be seen. We are the inhabitants of the golden middle. We live in a brief, flickering moment of cosmic clarity. We are the only version of the universe that gets to look at itself and understand the full architecture of the light. We can see the cosmic web. We can measure the distance to Andromeda. We can map the voids. This knowledge is not just science, it is a gift. A temporary, fragile gift from a universe that is in the process of dismantling every connection it has ever made. There is a strange comfort in our smallness. We often feel terrified by the millions of light years, the billions of miles, and the trillions of lost galaxies. We feel insignificant in the face of a void that is expanding faster than we can ever hope to travel. But consider this: in all that vast empty darkness, in all those billions of light years of silence, your mind is the place where the universe has become self-aware. You are the eyes through which the cosmos looks at its own isolation. You are the heart that feels the weight of the distance. Without the observer, the universe would still be vast. It would still be empty, but it would have no meaning. The distance is only terrifying because you have the capacity to measure it. The silence is only haunting because you have the capacity to hear it. Drift now toward the edge of sleep. Let the weight of the trillions of galaxies fade away. Let the expansion of space-time feel not like a threat, but like a slow, rhythmic breath. The universe is stretching. Yes, the galaxies are leaving us. Yes, but here, in this moment, you are safe. You are part of a planet that is still warm. You are part of a galaxy that is still bright. You are part of a story that is still being written. The isolation of the cosmos is not a prison, it is a sanctuary. It ensures that every island of light is unique. Every star is a miracle. And every moment of connection is precious precisely because it is so rare. We are the lucky ones. We are the ones who got to see the campfires burning in the dark. The light from Andromeda is still entering your sky. The Milky Way is still holding its 400 billion stars in a gentle, gravitational embrace. The great voids are still bordered by the glowing threads of the cosmic web. We are living in the most beautiful era the universe will ever know. And even if we are destined for a final, absolute loneliness, even if the sky eventually goes black and the last message from the last galaxy is lost to the redshift, it doesn't change the fact that we were here. We saw it. We measured the distance. We looked into the void and we did not blink. We are the memory of a universe that is slowly forgetting itself. Listen to the silence now. It is no longer the silence of the intergalactic wasteland. It is the silence of your own room, the silence of your own breath, the sukoon of a journey completed. The distances are worse than you think, but the reality of your own existence, the fact that you can look up and wonder, is better than you could ever imagine. The void is not your enemy. It is the canvas upon which the stars are painted, and as the stars fade and the night takes hold, you can rest in the knowledge that you have seen the truth. You have crossed the unreachable gaps. You have looked at the untouchable empires, and you have found your way back home. Settle into the deep now. Let the darkness wrap around you like a blanket. The expansion has slowed. The stars are still. The universe is at rest. You have carried the burden of the observer, and now it is time to set it down. Sleep in the warmth of the only galaxy you will ever know. Sleep in the heart of the light. The journey is over. The silence is complete, and the darkness is finally peaceful. Good night. From the edge of the void, good night. From the heart of the only home we have ever known.